Hey guys, this is Fozon, and in today's lesson we're going to be discussing ArrayList and its respective methods. So our lesson objectives, we're going to learn about what the ArrayList class actually is and its potential advantages, learn how to declare an ArrayList object and utilize its methods, and then finally we're going to learn how to traverse through an ArrayList within the compiler. So what actually is an array list? So I want you to think of an array list as an array. However, rather than establishing a length right from the instantiation, the array list starts with an empty list. So there's nothing there, but then you can add onto it, you can add objects, you can remove objects, you can change objects, and this has a potential benefit. With the array, we had to set a length right from the beginning. However, we didn't really use every single position. I mean, there will be some cases where we will be using all of the positions within the array. However, there could be cases where we're losing out on memory. We're not allocating memory efficiently within the array. So this is where the array list comes in, because there's really no automatic initialization when it comes to the array list, because you either add the object or you don't, and it can adjust its size whether you add a bunch of items or objects, to be more specific, or if you remove a bunch of objects. It implements the list interface, which you don't have to really understand now. However, it's very important when we learn about interfaces in our inheritance and polymorphism video, or rather section. But understand this, or just remember this, it implements the list interface. And since this is an ArrayList object, you will have to use a constructor. And by using the constructor, you create a new empty list. These are the different ways that you can declare an array list. The first example is, well, you have an array list. My list is equal to new array list. This just creates a generic type or a generic array list, but you're not really going to use this most of the time because it's too generic. You don't know what you want to put within the array list. You will most likely use this as a means for getting the array list through an argument. So rather than having an integer double Boolean string array list argument within another method, then you would much rather use this as a generic type, because you don't know what type of array list you are getting through the arguments. If that doesn't make sense, you'll see when we're trying to traverse it via a different method. But the way that you're going to declare an array list object is most likely through these examples. So if you notice, we have a capital I and then integers spelled out. We have double spelled out, we have Boolean, and, well, string is string because string is not a primitive type. But what you notice here is that the array list object doesn't take primitive types. The parameters that we have for an array list, by the way, the parameters are within the less than and greater signs here, the brackets that we see here, and we also put them after the array list, but before the constructor parentheses. So what I'm trying to get out of this is that you can't use the primitive types within the array list declaration. So rather than using the primitive types, we have to use the wrapper class equivalent. So this is actually the integer wrapper class. This is the double wrapper class. This is the Boolean wrapper class. String is the same because as I told you, it's already an object, a string object. We also can put, well, regular objects within an array list. So we can actually create an object and then we could fill the array list with a bunch of objects. An example that I have here is a bank account object, and, well, I can put bank accounts within my array list, just like how I can put bank accounts or other objects within my array. It's the same reasoning, it's just a different form of data collection or data storage. So with the ArrayList class, since you're creating an ArrayList object, comes a bunch of methods that you can utilize, and, well, they can serve useful depending on how you use it. So the first the first method of the ArrayList class that I'm going to discuss is the size method. What the size method does is simply returns the number of elements within the array list. This is equivalent to the dot length function, not necessarily function, but the dot length feature of the array. But it's important to note that with the array, .length did not have parentheses since we weren't creating an array object. Array was just a form of reference type within Java, so it didn't have the parentheses after. However, since we're creating an array list object, in this case, we have parentheses after size, and this simply returns the number of elements within our array list. The next method is add, and this simply adds an object to the end of the list. And if you have only one argument within the add method, it's going to return a Boolean value. That Boolean value, as I put in the PowerPoint, is going to be always true. Most likely you won't need the Boolean expression that it returns, but you will have to remember that it does return a Boolean expression. E just represents a data type that you could put within the array list, and then object is just an identifier. You can input values within the array list either through a variable or a directly. So I can put maybe integer x is equal to 5, and then I could call the array list dot add and then put x within the parentheses, or I could simply skip that extra middleman and put 5 within the parentheses. Again, it will make more sense when we look in the compiler. So with regards to two arguments within the add method, this adds a certain object in a certain index within the array list. So the previous add method, what it would do, it would put the object at the end of the list. However, you might not want it at the end of the list. Maybe you would want it at the middle of the list. So if you want it at the middle of the list, then you would have to access it through the index. And the index is just like the index is that are in an array. It starts at position 0 and it goes all the way to the size -1. And once you add this object into the array list, the size increments by 1. So in this case, I have 45, 50, and 60, and I want to make this array list have values that add 5 to the next value. So we have 45, we have 50, and then it goes on to 60. I want a value 55 in between 50 and 60. So what I will do is that I will add a object, a 55, at position 2. Now, why do I say position 2? Because we start at 0. So 45 is position 0, 50 is position 1, and 60 is position 2. So our index is going to be 2, and our object is going to be 55. And then this is the end result. This would have been hard within an array, because an array we would have to make probably a new array, then have it set to 4 elements, and then we would have to get all the values from our previous array, input it within the new array, but then skip this position so that we would add the 55, which is a big hassle. Luckily, the ArrayList class makes it easy for us by doing so through one method call. Now, to actually access values within the array list, you use the get method, and what the get method does is that it returns the object that is located at the desired index. Again, it will follow the rules of position that I previously said, starting at 0, with the final element being size -1. And it returns the object, and I have E. E is just a fancy way of saying the respective object that is located there, the data type of the respective object. Now, if you don't want to add something but change a value within the array list, well, you can do so through the set method. So it takes in 2 parameters or 2 arguments, integer index and then an object. And rather than adding it and then moving all the values to the left, it will simply take out the value that is at that element and then input the value that you put within these arguments. So it's just a simple swap. Replaces the element at the index. And then we have this method called the remove method. All this does is that it removes the object at the desired location, and then it subtracts 1 from the size. It's also important to note that it also returns the object that you're deleting. So if since it returns the object that you're deleting, then and then you could access it if you want to use it. So if you have a bunch of values or different numbers that you want to crunch and you want to remove values as you use those values, then this method would be good for you because it returns the deleted object to you as well as removing it from the array list. So we have 45, 50, 55, and 60. And if I say I want to remove position 2, it's going to remove 55. And then it will do the readjustment for us so that there is no empty location at position 3. We just subtract 1 from this position, so 60 is going to become our new position 2. And if there were other values after position 2 or position 3, then those will be decremented. So let's go on to the compiler and actually try out some of these array lists with their respective data types. Oh, so that's the next section. So I'm in the learning array list class, and I have a bunch of methods already set up for our learning or for our lesson objectives, with the main method being empty because I want to tackle all these methods one by one, and hopefully we can work on the methods and practice the methods that we have in the array list class. But the first thing that you should be doing is actually importing the java.util ArrayList class. So the ArrayList class is part of the java.util package, and you could do so in two ways. You can do java.util.ArrayList, or you can put all the classes by putting an asterisk like this. However, since I'm only using an array list, I'm going to only import the array list for now, the ArrayList class for now. So now it can utilize the ArrayList class, meaning that I can create ArrayList objects from the ArrayList class. So let's start off with our basic integer array list. So we have an array list, and then within the parameters, I have an integer, meaning that I will have integer values within my array list. I'm not going to have Boolean values. I'm not going to have string values. I'm going to have integer values. This is my identifier for my array list in case that I want to access my array list object. This is the identifier, and we're accessing the constructor of the ArrayList class, and through the constructor of the ArrayList class, we're saying that we are creating an integer array list. So our array list should only have our integer values. Again, recall that we should be only using the wrapper class equivalent of the primitive types. All primitive types have wrapper class equivalents that all create a object version of the primitive type that has respective methods that get inherited through the object class, as well as a bunch of other methods that are included within maybe integer, double, or Boolean. So don't put int, make sure to put integer. So to actually add value, you have to access the add method of the ArrayList class. So since this is an object, this object has methods that, well, it creates. So we have an add method, and I want to add these values. So I have our AL, that's the identifier. Then we access the add method, and we put in the values 1, 2, and 4 in that order. And in comments, I put their respective positions, 0, 1, and 2. So as you can see, we have a bit of an issue. We want this to be in numerical order without skipping any numbers, so it's 1, 2, and 4. However, we have a 4 and we only want 3 numbers, so we need to replace this 4 with a 3. But before I do that, let's actually see how this is printed out. So I access the printAL method. This is a method that I've created. It's all the way down here, and this is done so through a for each loop. Yes, an array list can be utilized with a for each loop, which is a very good advantage. There's also a way that we can traverse it through a regular for loop, but again, we'll tackle that at the end of the video. So it will invoke that method when it's printing it out. So let's actually see what is printed out when we access this method that has this array list. and we have 1, 2, and 4 printed out as a result. Now, well, we also have the size. I made sure to implement the size. So this actually accesses the array list size through the size method of the ArrayList class. Anyway, that's going to be an advantage just to show you how, or keep track of the values that we have. So what if I want to add a 3? Well, I could do so very easily. I could do this in 2 ways. I can do, well, not just 2 ways. I could do this a bunch of ways. I could put the add method here, and then I could simply put 3 here. Oh, we got an exception because we didn't use the correct identifier. And as you can see, it increments the size by 1, as well as putting 3 in between 2 and 4, because that's how I use the add method. But what if I can't put something before 4, or the dot add of the 4? So what I can do is I can actually remove 4. So let's do our al dot remove, and let's remove position 2. What this does is that it removes the 4. Now I want to add a 3. And as you can see, it removes the 4 first, and then it adds the 3 to the array, to the array list. And when we remove the value 4 from our array list, position 2 technically speaking, what it did was it decremented the size as well. We could do the same with the Boolean expression, or Boolean array list. Within my Boolean array list, I have a ArrayList Boolean. Again, I have a wrapper class equivalent with a capital B to emphasize that we're creating a Boolean object, not a Boolean primitive type, primitive data type. This is our identifier, and then we access the constructor of the ArrayList class, saying that we have a Boolean array list that we want to create. And what I do is I have 4 values that I'm adding to the array list, all of which are false. So let's see how it gets printed when we access the print al method. So let me replace int al with boolean al, and that's how it is spelled, so that should hopefully execute. So it prints out all false values, but most likely you won't have an array list with just false values. For the purpose of this demonstration, what I'm going to do is I'm going to try to add a true value within the 2 false values here. So I could do this technically 2 ways. What I can do first is I can actually use the set method of the ArrayList class and replace the value at position 2 with true. So what it does is that it swaps the value of false in this location over here to true. However, that isn't really symmetric yet, so we can add another false statement. And what that does is that I forgot to make that identifier capitalized. And what that does is that it makes this more symmetrical. We have 2 false values before the true and 2 false values after the true. However, this can boil down to 2 statements. So what I can actually do is I can do our al.add and use the 2 argument add method. And what this does is that we can put our value at a certain location. We can insert it without deleting any of the other elements. So I want to insert this at position 2, and the value that I want to insert is true. And with just one statement, we get the same result. Now, a very powerful application of ArrayList is that you're most likely going to use on the AP Computer Science exam is the string ArrayList, because you could store a bunch of things and has very powerful applications, right? You can maybe even store a sentence, you could store grades with people's names, yada yada yada. But just know that if you're going to see an array list within the AP Computer Science A exam, it's most likely going to be some string array list. I mean, after all, that was the array list that was on my AP exam. Anyway, I have 4 different values within my, I have 4 values being added to my string array list. Again, I create a string array list, and I make sure to emphasize within the parameters that it's a string object. And then I insert these values in their respective orders. Hello, this is Fozon. So at position 0, it's going to have hello. At position 1, it's going to have this. At position 2, it's going to have is. And at position 3, it's going to have Fozon. So what happens when we print out our array list? So hopefully that is the name of the method. And as you can see, it prints out a sentence, or more specifically, it prints out this array list values in order that they were added. Now, what if I want to change the name of Fozon? Well, rather than doing so within the add method that we use for Fozon, we can use the set method. So we could do our al.set, and we could do position 3 since this is at position 3. And let's say we don't want to say hello, this is Fozon. We want to say hello, this is Umar. Then we can make that respective change. Again, it has to mimic the object that you have there. And it makes that respective change. So it swaps Fozon out and puts Umar in. Now, before I get into a potential application of ArrayList with objects such as the bank account or student account, a student, I want to touch on objects, an object array list. So I create an array list and I have it set to an object array list, meaning that's going to take objects and then it could store objects within the array list that we have created. Now, you're probably wondering, wait, why do we have object? Well, remember from our inheritance hierarchy within the object class video, object is the universal superclass of every single class that we create, and that includes the wrapper classes as well, because the wrapper classes, they inherit methods such as toString or the equals method from the object class. So all of the classes that we see within the Java programming language are ultimately objects. That's why we say object. These are array list objects. This is a string object. This is an integer object, because everything is an object. Not everything is a string, but all strings, all integers, integer objects are, objects. So would it be possible to put a hello string, a integer 10, a double 3.14, and a false value within an object array list? I want you to ponder on that. Well, if you said yes, let's see. Let me put that. Hopefully that is the correct method name. Okay, so we just needed to save that. And as you can see, it works. And the reason why is because we created an object array list. So it expects objects to be within our array list. And are these all objects? Yes, they are. Strings are objects. Integer objects are objects. Double objects are objects. Boolean objects are objects. The wrapper class equivalents, if you create it through a wrapper class, are objects. Now, these are integer objects because it expects them to be integer objects. It expects this to be a double object. It expects this to be a Boolean object. And the reason why I keep saying object is because these wrapper class objects are different from primitive data types. So these are not primitive types. These are, the integers, doubles, and Boolean values are primitive types because the wrapper classes have instance variables that are primitive types, but it also has a bunch of methods that we use with it. But since we are using the ArrayList class and it is using the object equivalent of those primitive types, and since these are all objects, we can put them within an object array list. It is possible. Now that's not something that we could have seen with, now that's something that's very different from the array. Anyway, let's move on to bank account AL. So what I did was I created a bank account array list, and within the array list, well, before I put any values within the array list, what I did was I created 3 bank accounts. BA1 with the name Fozon, another bank account with the name of Umar, and a third bank account with the name of Vikram. And just to show you the bank account class that we've used a lot of times, it has 3 constructors, and the one I'm using just for the purpose of this video is string name, because it's very easy to create a bank account object and differentiate between these bank accounts based on just their name, rather than accessing the constructor with no arguments or creating different values for every single bank account that we create through the 3 argument bank account. It's also important to note that I override the toString method of the object class within the bank account object. So rather than returning the object location of the bank account, it's going to return the name when I access the identifier. So when it's trying to invoke the toString method, it returns the name. So we will be saying the name rather than the object location. Anyway, back to the video, or back to the class that we're actually dealing with. We have a bank account, we have 3 bank accounts, and they have their respective names. And then I add those bank accounts within my array list. Now, we can technically skip all these 3 steps altogether. What I could have done was that I could have simply put new bank account, and I could have put it within the parentheses here, and this would have worked. Let me remove BA1. This would have worked because, well, this is creating a bank account object. However, just for the purpose of visualizing how it works, I created the bank accounts separately with their object locations, BA1, BA2, BA3, and then I add those object locations to our array list. Now, if I print out the array list, what does it print out? So let me do bank account AL, and let's see what it prints out. And it prints out, well, invokes the toString method of the bank account class, the one that it overrides from the object class. And the reason why it does that is because of the for loop values that we have. So if you look within my for each loop, within our for each loop, it has an object, val, and then our array list. Now you're probably noticing, wait, why isn't there a type within our array list parameter? So why don't I put like object, for example? Why don't I put string? Well, the reason why is because we want to use this print array list method with as many array lists as we can, or any array list for that matter. Now, if I put a object array list, or if I specify object, or if I specify integer, or if I specify string, it's going to expect a object array list. It's going to expect the string array list. It's going to expect an integer array list. But I want this array list to work with all array lists. Or sorry, I want this method to work with all array lists, because we're simply printing the values and accessing the toString method when we invoke the values that we're iterating through. So by using this declaration of the array list, it's just going to set it to a generic type that is subject to change every time we invoke this method with our array list parameters. Right, so at one point it could be an integer array list, at another point it could be a string array list, and another point it could be an object array list. But the important matter is that this one method can work with all the array list methods array list types that we have out there. And as I said, the for each loop works with the array list. However, what if you don't want to use the for each loop? You want to use the regular for loop? Well, that works just the same. What we can do is do for integer I is equal to 0, I, is less than, we call our array list. So our array list name through our parameters is our al or our al. And rather than saying dot length like we would use within an array, we would use dot size, because that actually gets the number of elements within our array list. And then we increment it through every iteration. Then we want to print out the values. So let's print out the values. That is not a semicolon. Okay, so hopefully that worked. Now we want to do system.out.println, not println, print. And let's print out the values within our array list. So unlike the for each loop, well, the for each loop had a variable name. We don't get a variable name within a regular for loop to actually access values within our array list. So we would have to use their respective positions. So with an array, you would access it through the brackets. Through an array list, you need to access it through a method. So we do our al. The method that we use is .get, and then the arguments that it takes is the index. The index is just simply the loop control variable that we utilize or that we declared within our for loop. Let me just add a space just so that we can differentiate between the values, and our for loop is created. So if I run the method again, actually let me do all the values at once. So we have int al, all the methods at once, sorry. We have Boolean al, we have object al, as well as, I believe we had string al as well. So let's see if this works with all the methods that we have. Let's run it. And as you can see, with every single method that we have there, it works. But the one that I want to touch on specifically is, well, bank account, because that was the one that we just touched on. Fozan, Umar, Vikram, those are our bank accounts. And when we invoke the toString method of the bank account class, when we're accessing the bank account value, then it prints out the names that we have there, just like it had within our for each loop. And that's just how you traverse through a array list. The other way, as I said previously before, the regular for loop was just through the regular for each loop. But you would most likely use this if you require a position that you might need. Maybe you're using a searching algorithm, or you just need the position to store value. Anyway, this wraps up my video on ArrayList. I hope you enjoyed it.